Hey guys, so I'm back with week 5. I have just done the lab. Okay, it was a bit tedious because it had recursion again, and recursion takes a lot of time from me because it's a bit complicated, I guess. Even if I watched many videos for it, I don't know why, but whatever. So as you can see, I opened the Tedman, the problem we solved before using recursion to get like my mind refreshed on it. Also, I opened the tree.c file from the lecture to get my head around making a tree, because that's what we are going to do in this case. So basically, let's see. I watched many videos on the topic, but on the lab, but they really don't explain the recursion case. Most of the videos like tells you to go to this link, coding path, where you will find some cases and examples for recursion, and if you solve it, you would be able to understand the case better. But I didn't solve it yet, but I guess it won't explain it in the way that I would want, I guess. So I watched the video by Abdul Bari, I guess. He's an Indian teacher. He's a great teacher, actually. I'm going to link his video in the description and in the comments. He was talking about recursive tree, and he went in each cycle of the recursion case one by one. He stated the recursion case clearly, which helped me a lot in solving the problem, basically, and understanding it, which is the most important thing. So let's see the problem, and let me try to explain what I got from the video. So basically, what we want to do is, we have a child node, and we have a parent 1, parent 2, or let's make it parent 0 and parent 1, and from parent 0 and parent 1 we have parent 0 and parent 1, and the same from here. If you look at the problem like that, it seems a bit complicated, okay? But the way we are going to look at it is, let's see the thing that recurs or can be repeated, I guess. Like if you look, we always have this triangle in our case. We also have it here. Okay, and we also have it here. Okay, and we would also have it for here, but we already stopped at generation 3 for the grandparents in the problem we have here. So basically, this is a child, this is the parents, this is the grandparents level, this is the grandparent level, this is the parents, this is the child. Okay. First thing that we are going to do is allocating memory for each node we pass by. So here we write person p malloc size of person, which will give us the size of the struct without determine looking into the struct and seeing if it have int. We would give it an amount of bits, if it have characters and so on, just using size of and writing the name of the type, the new data type or the structure we made. Will just give us the exact amount of memory we need for exactly one node. Okay, so here we stated the first node. Okay, we would need to check if malloc gave us an actual space and not null, but I really didn't know what to return if we found that case, because the function we are in needs a pointer to be returned to it. So I just didn't look really into it, and it didn't really affect the problem. So I will search on it later on. Anyway, so after allocating memory for the first node, we will go and say if generations is more than 1, like generations is a global variable we set at the beginning here, which is 3 because we have 3 generations, 1, 2, 3. Okay. So generation is now 3. So the condition is accepted, and we go into the if statement. We see that person, the new data type we made, and parent 0 is a pointer, and we go into create family. Create family is the name of the function we have, and each time we call the function we subtract 1 from the function. So let's look into that. So basically what we will have is this big red. Okay, red. So at the start we will have this node like this. Okay, and this is the one that we made. Okay, then we will point it by, like, say 1, number it by 1, and then say we make the call of creating the family. Okay, we are calling parent 0, like I missed the point, I guess. Anyway, this is the first part, P, and we go to the node next, that is next. This is gonna be allocated, like if we're gonna make this call, so we start the function again and we allocate the next space, which is gonna be malloced. This is the second node, and then we call this node, this line again, which will call the function. So it will give us a new malloc, which is 3. Okay, and at this part we will have generations not more than 1. It will be equal to 1 basically. So we will not go into the if statement, but we will go into else. Okay, At this stage we are at the grandparents stage. So here what we want to do is basically like if we look into this node, you will see it divided like that. Two parts for the O and A, maybe A and B, the blood type, and two parts for the pointers if we are going to make more nodes from it, like if we're gonna go like this and this. But actually we only have 3 generations, so here we need to put null. Okay, these two parts gonna be null. So after we found that generations is now 1, which is not more than 1, so we go to the else statement. And at the else statement, as I said, we would need to put the pointers at null, which what we did here. P refers to parents, the first index of the array, and parents array, or you could say array of pointers would be null, not pointing to anything. And the second part of the array, or the second index, will be also set to null because it's not pointing to anything. Okay, that's for the pointers array. What about the Alice? I don't really know how to spell it or I mean pronounce it, but this is related to the blood type, the array of the blood type. And because we start from the grandparents, we would need to set a random value for the blood type, like O and A, A and B, B and A, anything. And fortunately, CS50 gave us the function already made, like it's already made in the file. We do not need to make any extra work. This will basically give A sometimes, B sometimes, or O sometimes, randomly using the rand function. So we just call it, we use B and the arrow, and we state the first part of the blood type using the index 0. Then we call the random array, I guess, function without putting any input. It will just work like that. Okay, so we will repeat the same thing for the second index, and by doing that we filled the third node we have here. Okay, so what's next? We have return B. What is that? We will return the pointer pointing to this place, like it will stay. Yeah. Return B will give person. Yeah, here currently we treated this as B, this as B or B1. So B is the pointer that points to both nodes. So B will be currently, for us, if we return it, it will be B0. Okay, if we look at it from the node 2, so we return it. Okay, after we return B. If we go back to the last part we were in, we only called the first line. I just want to remind you, we only call the first line. So the return statement will replace this part with B. Okay, the pointer to this place, this node. Okay, and then we will start calling the next line, parent1. This will call the main function. We will go to the main function and malloc the right side of the tree, of this small tree or small triangle we have. So we go from 3, let's say we are at 4, like the steps we are taking. 4, we are here now, and from 4 we will go to 5, which is the new node we just allocated, and generations were minus the 1 again, and we will see that we cannot go into the if statement, and we will repeat what we just did in the else statement again, but for this node. Okay, settings post pointers to null, and setting a random value for the blood type, and return P, the pointer pointing to the node 5 here, and that pointer will be assigned to parent1. So do you see what we have here? Like we got back to this line, so we will continue from it. Okay, so what do we have here? It says parent, like what the problem want us to do, set parent pointers for current person. Okay, so here for this, like if we got back from 5 from this node 5 to this node again, so we'll say this is the step 6. So we need to assign values for this node, and it will not be null as we just did with the grandparents nodes. So how do we get the values for this pointer, and this pointer, to set the memory address of them in both of those places, as we just did with the return statement here? We assigned the first pointer to parent 0 and the second pointer to parent 1. So we have everything stored. So what we will do is go to this node now will be considered the B. Okay, like if we get this is B, and this is B 1, and this is B 0. We will go into the parents array that holds the memory addresses, and set the first index with parent 0, which is the first memory address of the pointer. The pointers that holds the points to the memory address we allocated this node for, and the same for parent index 1. We'll do the same thing, and by doing this we assigned both of these places, this place and this place, with the memory address of that with the pointers that points memory address of the pointer that points to both of these nodes. Memory address of the pointer that points at both of these nodes. Okay, so what else? We also need the blood type. Okay, and it will not be randomly selected like before. It should be random, but from the values we have. Like we have here O, maybe A, and maybe you could say A and B maybe. So we need to select from these values. So what we are going to do? Okay, so we will do the same as previously. We will access P and go to the first index of the blood type, and then in the video Brian did something, I don't know if it's necessary. He first accessed the parents from the P variable, and then from that he accessed the arrays of it. But you could do the same by using parent1, for example. Maybe he didn't want to confuse us, which confused me, like this long line or this line, you know. This, I guess, is better if you read it closely. What does this do or wants is it focus on parent1. This is parent1, and it access its values, which is arrays, which is a blood type, and inside, instead of writing 0 or 1 like choosing A or B, you know, we want to choose a random value from them, random, like without writing it each time. So we used the random function. It gives us a value from 0 to 32,767. Okay, you would say we only need 0 or 1 because that's the size of our blood type array. Yeah, that's why we added the remainder and 2. If we divide by that, we would get only 2 values. If the number, that random number that the function gives us, is even, then we would get 0. And if the number is odd, we would get 1. Alright, so ultimately this statement will give us 0 or 1, which what we want. So yeah, this allocated this part assigned values for the blood type for the parents. All right, so we still need to assign values for the child. Okay, so we after doing this part, we will go to the return P, which will return the pointer that pointing to this node. Okay, pointing to this node. It's just yeah, let's continue. Red. So this is 6. We are going back to the main node. Let's write 7. All right, and from 7 it will start allocating more because like, let's see, we were going like this from here to here to here, and then we went back to here again, and went back to the right node, and went back to the main node, and went back to the main node again. but we still, oh yeah, at the beginning, the main node needed to go to this side, but it didn't have the chance because we went to the left sides until we met the base case. Yeah, you need to look closely at each case to figure that out. So basically we would draw or assign, allocate a new space using malloc, and here we are calling the second line. Okay, it's all about the second line now, and we will do the same thing we did previously, second line, and we will go like this. So if we say 7 with 8, 9, and from 9 to this node again, say 10, and go from here to here, and say this 11, and go to here, say this 12, and go to the base again, which is 13, and here we would assign values of the child after we assigned everything here. That's how we work it out. This is how the recursion in this case work, but most of the videos like go over it fast and they don't really explain it. And even the video I watched, it was really it's not complicated, but it was not specific for our case basically. So I guess this would be better, like if you look at this drawing and walk with your problem, you would understand it, I guess. And if you have questions, leave it in the comments down below. Okay, so yeah, we allocated our tree and we have it ready and set. Do I have any notes here? All right, the second part is, I guess, not that bad. We just need, let's move this part from here and write it here. We need to free everything after we allocated. We just allocated the tree and we printed out the tree. Okay, like if we try it here, if we try it here, let's write we tried to run Valgrind to check for memory leak. It says all heap blocks were freed, no leaks are possible. And let's just run it without Valgrind. Okay, so we get the results printed out, so our functions work. So we need to deallocate memory after printing this. That's why we have the free family function. We input the head pointer here, and from that we find the next pointer and the next pointer, like, you know, we go from here to here to here to here, so on. We need to do it recursively to not write tons and tons of lines if this is so long and not only 3 generations. So how we do it? Like for any recursion case, we need a base case, and our base case, what do you think it's gonna be? Like, what's gonna stop us? Yes, that's right, finding null in this spot. Like here we have address, here we have an address, and so on and so forth. But the last node, what defines the last node basically, is that we have a null value. Okay, so let's walk it through. If b equals null, no, it's not the case. So we go to this line, free family, and we go from the main pointer to parent 0, which is this place, this node, and we call the function again, b equals null, no, not the case, and we go to this place, we see b equals null, yeah, that's the case. And notice something important. Notice that p is set as p arrow parents 0. Okay, this is important. Oh, this is an important note basically. But anywho, we found that this node is null. So it will go back. Okay, it will not free it because we still have this line, and we would go to this node and go to the second grandparent node, and it will find b equals null again. So it will go to the main node, and it will continue what is the rest of the function, which gonna be free b. Free b here will free parents 0 and parent 1. Okay, just writing b will free both of them. I read on Stack Overflow. I wanted to like understand this more. I didn't really get it, but on Stack Overflow, they talk about if you just write b or b and then specifying a specific pointer from the array of pointers. Do you have to do that, or you can just write b and they will all the things that the pointers point at will be freed? You know, you get what I'm saying? They have to do this. You have to do something like this, or you can just write free b. Like I tried what is commented here, but at the end I had like 24 bits that needs to be deallocated. Okay, which was the pointer pointing to the main node here, and I couldn't write free b when those were not commented, so I had to write it in the main function, and it worked. Like I did the check and the code worked, but I don't really know why, you know. It got me confused a little bit. I really need to look into this freeing part. But yeah, basically when we are here, it will activate free b, which will cancel this one and this one, and so on. We will go to the main node, and then to this part, to this part, then to this part, and it will cancel this part and this part. Then we will go to the main node, and then it will cancel this part and this part, and then it will go to the pointer and it cancel the pointer. The pointer will cancel what is it's pointing at, which is this node. And you will have a free no, you will have no leakage, basically. No leakage, no leak, no leak. You know, so like if you want to visualize it again, like if we have here, make it more clean, this okay, let's see, blue, okay, so let's see what's gonna be deleted first. This part first, okay, then this part, then this part, then this part. It's really important to take care of the order of freeing the memory, because if you free something and you didn't free something below it, like if you free the main head, like if you just write free B and you free this part, so how we are going to free this, man? How? We have no address for it, like we lost the address, you know? So this would be incorrect. You have to free things from the bottom first and go upwards. Okay, and I guess that's about it, you know? Is there anything else I wanted to point out? Yeah, that's about it, guys. I hope that this explains things a little bit well, maybe, and it would help you, I guess. And if it did, please leave a like, subscribe, and leave me a comment of anything you want to see in the future. And if you have comment on my way of solving this, please comment it, and let's share the ideas. And if you have a better solution, like tell me about it, like share the ideas and so on. This was CS50. Bye bye.